So back in April of this year, I made this. It's a replacement of my arm with a custom modeled robot arm that I textured and built. And the purpose of this sequence was to show that object replacement is possible in 3D. You can create an object that will follow the orientation of a real world object in live action footage, and then you can composite something that looks pretty real. Now obviously this robot arm didn't actually look real, it's kind of cartoonish, but the point was to build something that looks like it could be real and looks like it does something and follows a real world object. And for me, limb replacement in a visual effects shot is pretty cool always. So really what you're seeing is base footage with an object on my arm. I used a cardboard box with a bunch of markers on it, tracked those markers, then modeled an entire robot arm, parented all those pieces together, tracked that cardboard box on my arm, and then did the animations, and then a lot of compositing, and we'll get into all of that. And I'll kind of talk about how I integrated those 3D renders with the live action footage, how I married the two shots together. So this is the footage that I shot raw from the camera. As you can see, I'm in front of a blue screen. I have really long hair because this was back in April. There's some really weird things going on with the footage. There's some vignetting, color shifting. That's because of the extreme settings that I had on the camera. I used this. This is the Zcam E1. It's no longer available. It's a 4K camera, the smallest mirrorless camera that you could get on the market. It's for a very particular use case. You can program it using the SDK. You can send HTTP requests to change the aperture and all sorts of cool stuff. Maybe in a future video I'll get into it. I shot this at 1440p square. It gives me just enough detail to be able to get some solid tracks on that piece of cardboard on my hand. I've drawn letters and numbers all over it. I've put some colored markers on it, and that's all so that you can get a good track in Blender when you're tracking it as an object. You want to eliminate motion blur. How do you do it? Well, I shot at a higher FPS than usual. I used a very high shutter speed, which kind of messed up the amount of light that was being received by the camera. Higher shutter speed means less motion blur, but it also means less light getting into your camera. And I also upped the ISO. Right before the ISO would have made it all noisy. Here we are in Blender. You can do motion tracking for camera solving in Blender, but you can also object solve, so to speak. You can actually track objects and solve for their orientation. So as you can see here, for that cardboard box, I tracked each one of those numbers. You can see the track right over here. And since they were on different surfaces, really the surfaces were perpendicular to each other because they're sides of a box, it worked pretty well. I did get a little bit of motion blur because it's hard to avoid. This was good enough for our purposes. It's very important if you want a 3D object to copy a real live action object's orientation. I won't get into the details, but basically what I ended up doing is exporting the track points from the motion tracker, and you can do that right here, 3D markers to mesh. Then use the convex hull tool to actually make a 3D model out of those points. And in order to follow that motion, you have to have that object solver constraint applied. A lot of tutorials online for how to do this. This was the result of what you just saw, that object track. So once I had one object following the motion of my arm, I could hide that and parent the main mesh to that hidden object, where you can actually see what that looks like. That robot arm parented to my arm, following the orientation of that cardboard box. That robot arm obviously took a while. I had to go in and model this entire thing. Used a lot of references. References always help. And start copying some of those individual components and really try to understand how they work together. Thinking about how things work together, even if they don't 100% make sense, how they could work together. For example, we have some stepper motors, or what look like stepper motors on the back. This was textured in Quixel Mixer, which is a new texturing suite, very similar to Substance Painter. I love Substance Painter, but Quixel Mixer also gets the job done. For pieces that need a little bit more detail, it helps to have a texturing suite that can very rapidly get these details in there. The grunge and the roughness channels in your materials, that's important to have. You want to have enough detail. So I just applied an emission texture to that particular little piece so that there's some light shining inside the object. This is what it looks like in the render preview. You can see that light source, how it kind of adds a little bit of a technological feel. These wires will follow that arm no matter where it goes. They are hooked into those stepper motors, and those wires are following those stepper motors. How did I get that to work? Created wires and then gave them an armature, and then used something called inverse kinematics on that armature. It takes a target movement of a limb and then moves all those bones accordingly downward through the system. Hence inverse kinematics as opposed to forward kinematics. That would be like if I moved the base of my leg and then I moved everything after that. This is how animators get complex movements pretty quickly. This bone on the end, that blue bone, that's our IK bone. If I move that, the rest of the bone will move wherever that goes. This is the bone right before our IK bone. This is targeting that IK bone. And that IK bone has a child of constraint that is connected to that stepper motor. So the IK bone will move wherever this object is. And the base of that armature, the other end, is connected to wherever the wire originates. By combining IK systems and connecting them all together via parenting and child of constraints, you can create a very complex system. This arm actually opens and closes. That's an IK system system as well. You'll notice our other IK armatures are in place and work just as intended. Since this is a hard surface model, all of these individual components are actually parented to individual bones in this armature. This armature starts exactly at the origin of these gears, so it looks like they're rotating. They're actually parented to this bone right here. Think of this as a giant hierarchy. This guy is parented to this guy is parented to this guy. These armatures are actually parented to this guy here, all the way down to the base. So everything from here upwards through the system is parented to this pivot point here. I can actually rotate everything upstream from this one object. Modeling can get crazy. You'll never get something infinitely detailed, but you can get something that's convincing, and that's what I aim for. These wires in the back work the same way. The IK bones are instead made to follow this invisible object, so I can pull these wires off screen. We're trying to make sure those wires don't interfere with us. We can just pull them off screen like that. Our object goes way outside of the frame because our arm ended up being massive. So we actually want to get a lot more of this when we're rendering it so that we can composite it and have that entire arm in the shot, because we're going to be using a wider shot, 16:9 aspect ratio. I duplicated the camera. I actually move our camera by the local Z-axis, and I moved it directly back. What you don't want to do is change the focal length right here. We actually just want to back the camera up enough so that we get everything in frame. That's what we'll be getting. It won't be distorted at all. We're just getting more of it in the frame. So here's that final composite. You'll notice our robot arm is perfectly married to our body in this shot, and also there's some camera movement. We're moving around a 3D environment. Here's our main composite. Think of this as essentially two components, our rendered component and our live action component. This right here is our main sequence, and we have a key light effect applied to get rid of that blue screen. And most importantly, we have a ton of masks. Two of our masks, the blue and the red, are just garbage masks. So they're getting rid of the outside edges of our blue screen. But this mask is special. This orange mask, this is actually me masking out the cardboard box. To achieve this, you'll see all these keyframes. The track mask feature tracked it forward as far as I could. Sometimes the track would fail, and then I would hand keyframe it back into position. There are some slight corrections, but for the most part, this is the way it was rendered. But we still got problems. For one, I mean, it doesn't even cast a shadow onto my arm. I made a copy of our arm render. I applied a drop shadow effect, so you can see that drop shadow being applied to the end of my arm. Then I created a copy of our live action footage above that render, and I set the track matte to alpha matte of the thing above it. So this copy of our footage is actually being used as the matte for where that drop shadow is being put. By using that copy of our footage as the track matte, it eliminates the drop shadow where it would appear in thin air, and it only applies that drop shadow where it's in contact or would fall on a live action object. So it relies on the alpha of that footage. Now there are places where the robot arm actually won't cover everything that I masked out because it doesn't perfectly overlap with where that cardboard box was. For that, I have a solid that fills in those little gaps where my arm isn't. That is parented to a null. And that null object is the result of another track. You can see this layer called track. I've rendered out another render pass. You can see it here. That is just two dots connected to the track object in Blender. So then in After Effects, I tracked those two dots, assigned it to this null object, and parented that solid to that null object so it'll follow the rotation of my arm. That's really how it works, but we're not done yet. I also applied this effect, CC Force Motion Blur, to the render layer, the arm. It will actually follow the motion of every pixel in the render, and if it exceeds a certain threshold, will apply motion blur to those pixels that are moving above a certain threshold of speed. This stuff really sells your render. We get to our final composite, our final render. How did I get camera motion involved? I used actual Adobe After Effects 3D for this. Our camera, I gave it a slight keyframed motion. I set these objects up as 3D layers. But how did I get that 3D environment to move the same way? I exported my After Effects camera using a script into Blender, made a really quick hasty environment, rendered that scene out with my After Effects camera, brought it back into After Effects, and here it is right here. It's this sequence right here. This is not a 3D object because it's just the 2D background. The motion is already following our 3D camera. There's no need to make that a 3D object. So I color graded the whole thing. There are a lot of other components to this project that I didn't mention, such as the lighting, which is very important. But I hope this gave you a good overview of how this effect was accomplished. And if you'd like to see more of these overview types of videos that cover a specific effect, go ahead and subscribe because we'll be doing a lot more.